when it is visible to you. So I have when every is it visible? Okay. So thanks, Vimal Raj. So we'll start now. So our today's session basically is regarding the model analysis. So we will simply go through its theory. So again, same presentation I found out from Google. So it's available for everybody. So you just need to type model analysis plus Ansys in Google, and you can get this PDF. So let's start with the basic phenomena of vibration or free vibration, basically, and what basically modal analysis means and why we need to do the modal analysis. If in between, if you cannot get through any concept or what I'm telling, please raise your hand or you can simply unmute yourself and you can ask me. You can interrupt me at any point, right? So here we will just see like what basically the modal analysis and why there is a need of modal analysis. So here again, it has like they have explained in analysis system. Up until now, we dealt with static structural, and secondly, we dealt with buckling, right? That two phenomenon we are aware of. Now this one will be third, which is nothing but modal one. So now instead of static structural, I need to just drag and drop this modal system, or I need to double click on modal system. Theoretically, my modal analysis will solve this equation in the background, which is nothing but my mass into x double dot is my acceleration. Just a moment. Hello? Hello? Yes, sorry for the interruption. In modal analysis, basically, it will solve this state of equation. So, this is nothing but my equation of motion, which is not having my term of dampening. So here I don't have any damping, so it's like written over here, undamped. So my C term is 0, that's why it is not present over here. Mass into x double dot is nothing but my acceleration. K is my stiffness. Again, U or X you can say it. It's nothing but my deflection. So is equal to 0. So here I do not have any external force or load. That's why this term in the right is 0. And here this my modal analysis simply solve this equation. Again, in case of harmonic, we just solve these two. Maybe we have angle in that. So you just forget about this for time being. So just concentrate on the modal part. So here I have just rewritten this equation just by taking simply this phi out of these two terms. And yeah, finally I'll solve this equation. Again, I'm having some assumptions for this also. So my material should be linear elastic material. So this is my assumption. So small deflection theory is used and no non-linearities are included. So here actually basically this is the simplest form of non-linear analysis. But we generally say it as linear because only small deflection theory is used. That's why. C is not present. I have already told you like F is also not present. So the right term is 0 and structure can be constrained or unconstrained. So in the both categories, even if I apply any fixed support or if I don't apply also, my this calculation will solve. Right. So this is it. And again, same things, maybe point mass we can add. For example, if I am having any structure and maybe a bridge, and on that bridge, if I'm having some vehicle, but I cannot simply model that vehicle. So that's why I need some point mass. So what I will do, I will model my bridge, and instead of my vehicle, I can simply add the point mass, whatever weight I'm having of that vehicle. So that I can include here also. Again, same things in case of material properties. I need Young's modulus, Poisson's ratio, and density. Exactly similar to what we were required for my static or static calculations, I will say. Static structural calculations. Right? This is related to context. I'll simply go ahead. Yes. And again, if I want to calculate this modal analysis for a range of frequency, maybe if I'm having some part with me, and if I just want to calculate the frequency in between maybe 100 to 5000, so I can do that. If you otherwise, I can simply say it to 0 and I can find out all the modes or all the frequencies. That is also possible. Means both ways it is possible. I can calculate it in some range, or I can calculate it starting from 0 to infinity. So that also. So without any range, I can simply say software just to calculate all the modes. So that's one thing. Again, same thing. So I'll not go into this result portion. Okay, so here are the results. So same thing here, we can see the mode shape. So say similar, exactly similar to what we saw in case of buckling. But in that buckling, the mode actually it was occurring due to the external load. And external load was like in our case, it was some compressive loads kind of thing, right? But here, these modes, these are occurring due to vibration of my system. Getting my point? So just a comparison between buckling analysis and modal analysis. In modal analysis, my part was deforming due to external load. But here in modal analysis, my part is deforming due to its vibration, or I'll say uh, natural frequency. Natural frequency is similar to the vibration. So whatever I'm having due to my shape and size of my body. Right. And why actually I need this? So maybe you can see over here, like all the guitars, they are based on my vibration, because whatever you are hearing out of this, whatever sound it is generating, it is based on vibration, because one of my string, it is vibrating. And it is very important to design that strings, to design its diameter. If I cannot get that amount of frequency, then whatever sound coming out of this guitar will not match, or it will not be that much good. That's why my quality of that guitar is dependent on all the strings and all the frequencies that strings are generating. Second is like this bridge you can see over here. Maybe you might have heard if I'm having some soldiers and they are just marching from the bridge. So they just dissolve their group while they are traveling from the bridge. Means they just can't go by marching like left, right. They cannot do on the bridge. The reason behind that is if they have some frequency, maybe if they are marching in left and right, like that combination, so their footsteps, they are creating some vibrations. If that vibration matches with the vibration of our natural frequency of that bridge, then there are chances of collapse, means that bridge can collapse. So without any external load, just because of the vibrations, bridge can collapse. That's why always soldiers are asked to just dissolve their group while traveling from the bridge. So this is the reason. Uh, so that's why finding out the natural frequency is very important, because due to resonance means what? Natural frequency of the body if meets any external agency which is having same frequency. If for example, if my bridge is having maybe 100 hertz natural frequency, and if I am having some vibrator which is creating 100 hertz exactly similar to my natural frequency, and I just place that vibrator on this bridge, then this bridge may collapse, right? Because resonance will occur, and you all know very well that what is the phenomena of resonance, right? Because all would have done some experiments on that resonance systems. Fine. Again, same thing here. I can solve my modal calculations by two ways. One is like only normal calculations, means this bridge without any loads on it. That is one case. And in second case, we call it as like pre-stressed case. In that, maybe I'm having like 10 vehicles standing on that bridge. So that will be my pre-stressed case. So maybe bridge without any load will give me some natural frequency. And the bridge without maybe having 10 vehicles on it, means some load on it, will give me some other natural frequency. So those are two different cases. So one, I can say a simple vibration case, and second I will say pre-stressed case. Fine. So again, same thing for pre-stressed, they have simply added the term S, so which is nothing but a stress term in the same equation we saw earlier. I think that's done. So this is a general overview. If you come across any doubts, you can simply Google it out and you can try to learn more about the modal analysis, or maybe concept of vibration, or maybe concept of natural frequency. Fine. So now we will start with our calculation. We will first go through all the problems today. So this is nothing but my fork. You all must have seen this fork, or horseshoe fork, sometimes it is called. It is just simply used in case of that resonance experiments we used to do in our 11th or 12th standard. So this fork we will evaluate first. And you know that on that fork actually some frequency was mentioned in, like, or maybe marked over here. So it was in the range maybe 500 hertz or like 600 hertz, like that it was. So same thing we will find out today, by using the calculation from Ansys. Secondly, we have knuckle. So knuckle, it is used in vehicles. So we will find out like what natural frequencies the knuckle has. This is very important, because if my engine vibrations or engine frequencies, if they matches with the natural frequency of this knuckle, then it will simply collapse. It will simply crack from somewhere, and my whole vehicle will stand at same point, because it will not go forward if this breaks down. So that's why it is very important, just to avoid my all engine frequencies or vibrations to reach or to match with the natural frequency of this knuckle. Secondly, again, this is just I'll say a rough bridge. So not exactly bridge, but something similar to bridge. So here also we will try to find out the natural frequency of this one. And last case is wheel hub, basically maybe some sort of wheel rim, I'll say. And here we need to find out the frequency. And yeah, here we have one gear, a spur gear. In this also we need to find out the natural frequency of gear, because some all gears are used in gearbox, and all gearboxes has input from a drive motor, and that electric motor itself has some frequency, because it is rotating with some speed. And you know the formula very well. If you have some component, and it is rotating, then it is creating some vibrations, right? So you can simply calculate the frequency from the rotating speed, and you can simply calculate frequency of this per gear by using the modal calculation, and you can check whether my motor frequency and this frequency of gear is matching, or it is having some difference in them. If they are matching, then you need to redesign your gear. Maybe you need to add some mass, or you need to change your material or material density. So such steps you need to carry out in order to change the natural frequency of your body. Fine. Okay, then what I will do now, I'll go to the workbench. Let's start with our first problem for today. Before that, let me just check how many have joined today. Okay, so we are 12 now. Good. Okay, now we have seen a static structural, we have seen a buckling. Now we will see the model. So just double click on this model part. So some of my system will be created. So this is not here, it will be written as model. So my first part always should be just to save this. So I'll go to my directory. So assignment number 5, and I'll say session number 5. Fine. I'll save it. Now I'll go to my problem statement. Just I'll make 2 different windows. So I'm having material as structural steel, so that's fine. It has reduced my work, so I do not need to define the different material. And second one, I need to define element size. Okay, and I need to define the frequency range. So I need to find out natural frequencies for this 4, that too ranging from 0 to 1000. Means I only need to find out frequencies in this range. I will not go beyond the 1000 hertz. Means my frequency might be like 500, 100, like that, but not beyond 1000. Fine. So that's basically the range is. Constraint should be somewhere here. It has mentioned. So this bottom part I need to make fixed, and number of mode shapes to be found are 10. Again, in output I need mode shapes. So 10 mode shapes and corresponding frequencies, means 10 frequencies. Okay, fine. So my first part always should be just to right click and open the design modeler. So here I will import all these 3D files are saved in my directory. So I'll simply first of all go to units and set it to millimeters. Fine. Now I will select the plane. So I'll import my part on this XY plane, go to files, and what I'll say, import external geometry. So now I will import it from assignment number 5. Okay, so now I'm seeing this 4. Right click and say generate. Okay, perfect. So here I am having nice and good 4 available with me. So now what I will do, so here it's actually transparent, so I can simply change it like from frozen maybe in the view. just I need to untick this frozen body transparency. So if I do that, you can see over here, I can see the part. So both way, it's as per you, at like what you like. If you like to have to be seen it in a frozen or transparent way, keep it as it is. So it's up to you, totally up to you, what you like. Okay, so I think my part is done over here. So if you want, you can simply rename also here. It just right click and rename and say for. So just for your information, if there are multiple parts, maybe 4 5 parts, you can simply rename it from here. Just go to right click and say rename. So you can rename it. Fine. So you go back to main project window. Now double click on the model. Now because work has been done, now into the mechanical. So here you can see at the bottom starting mechanical. So here you can get whatever update is going on, right? So you can see from this point. Even here also, if you are giving some run, so in this show progress, you can see how much run has been completed. So it gives you one bar. Like if you are copying something from some directory to some other directory, if you are there, you are getting some like horizontal green line. So it is showing you like how much percentage has been completed. So same thing will be showing over here. I'll show you when I'll give one run. So in that case, you can see over here like how much of percentage of your run has been completed. Fine. So still it is opening my mechanical. Today it has taken a lot of time. Fine, because you know why? My model size, you can see over here, 6 into 10 raised to 3 millimeters. It's my this model is too much, like very huge. So maybe whoever have designed this, he surely have missed the units. Fine. So he would have created this fork in meters. That's fine. It is not hurting me now. Let's go forward. So just check the material. It's structural steel. Before that, just check the units. Okay, millimeter kg. Now, in meshing, it has been told that use a global mesh size as 60 millimeter. So in mesh, I'll go into the sizing and there I have element size. So I'll simply put 60 millimeters. Fine. I'll right click and say generate mesh. Okay, nice. So I have very nice mesh over here. Let's now go to the boundary conditions. I need to define the boundary conditions. So in the setup stage, so pre-stress, it is saying none over here because I haven't defined any load on it. So for time being, just forget it. So we will first do all the calculations which are like without any preloading. So now in analysis, what I need to define the frequency range. Here I need to define it like starting from 0 hertz to 1000 hertz. So there actually I'm having. So here you can see the maximum modes to be fine. So they are 6, but what I want they should be in the range of 10. So number of mode shapes to find are 10. So I just simply change it to 10 from 6. And here limit search to range. So basically by default it is saying no, means it will start searching the modes from 0 hertz until we have requested. Maybe instead of like 10, if I have given like 100, then starting from 0 it will search next 100 modes. 100 modes means 100 frequencies, so it will not go into the range. But now if I'm saying S instead of no, then it will just find modes from this range. So it will start from 0 and it will end its search on this number, like whatever maximum range I have specified. So in my case now, it's 1000 hertz, right? So it will only find this 10 mode shapes in this range and not beyond that. So yes, now I have defined my all inputs in analysis. Now I need to define the fixed support. So where I need to fix my model. So just right click, say insert, and go and say fix support. Or you can do one way, like if you do not like to press right click, just go over here. In case of support, you have that fix support. In loads, you have force, pressure, everything. But currently we are in the modal analysis, that's why they are not visible to you. If you are in static structural case, you will have that all menus available. So I just click on fix support and I simply select these two faces which are to be fixed. Okay, perfect. So now my part is done. So what I will do now, I will simply go and say solve, or I will just hit F5 as a shortcut to solve. So yeah, I told you I will show you the progress also. Oh, I think mine has got completed. Oh, it's done. So that's why I can't see that progress. If it is in case of like large one, so it is very useful to see how much progress I did, how much percentage of them it got solved. Mm, Now I need to go on the solution just to check the frequencies. So I can simply drag it a little bit on upward side. So you can see I have the 10 modes. So 1, 2, in that also you can 1 to 10. So first one, second one, third one. So it has started with 0 and 1 and 7. Only 10 because I requested only 10, so it has found for me only 10 modes. But if I would have like given instead of 10, it would have again little bit more. It would have reached to the 1,000 hertz. So results. Oh, something has clicked. Just let me know what changed. Is my screen still visible?
No, sir.
Hello? Yes? Praveen, please.
No, sir, not visible, sir.
Okay, since when it is not visible? So, or just, okay, just disconnect. Okay, fine, fine. So something I also got some tick tick sound. Maybe that's why. Okay, now I'm presenting it again. Uh, Please tell me if it is visible. I think it is, right? Is it visible?
Yes, sir.
Yes, sir.
Okay, fine. So what I did, I simply let me go to the solution. Okay. So what I did, so I just clicked on the solution part. So here I got one table and one graph. So this graph is showing like number of modes, starting somewhere here 25 to maybe 197. These are my modes, and they are like visible in this chart also. So I'm having this table showing me uh, 10 modes. Simply okay. So 10 modes I'm having over here. So now what I will do, I will select this all rows and columns by clicking in that empty cell, and by clicking on like just right click on any selected cell and say create mode shape results. So by doing this, all these different results will directly in your solution. So maybe in post processing. And after that, you just need to right click it and say evaluate my result. You will get this nice result. So for time being, I'll hide my mesh just for the purpose to see deformation in my fork. Maybe I'll reverse it in such a way. Let's see. So this is my first frequency. This is my first natural frequency. My first natural frequency is around 22 hertz, and with that 22 hertz, I am having this much deformation. Now, very important point is don't go on these deformations. So this may give you exaggerated view. Maybe this fork is deforming with this much deformation, like that. So, but here important is just to note the natural frequency, which is 21.792 hertz. If I just hit this fork on maybe some material, so I will get my first frequency as this one. Second is 22.2. Again here, just look on this deformation. These deformations are increasing. So here 48 hertz. So likewise, my 10th mode is at 197.67 hertz. So you can see the difference. So now my this end of fork is simply lifting up, and this is lifting down. So it is tilting, and it is creating me a frequency of 197 hertz, right? So those are nothing but my mode shape results. And here maybe I'll go here, so this will be very nice to see. And what I will do, I will scale it little bit up, so maybe 3.7, or maybe again little bit up, 9.7. Fine. So this is very important in case if you are presenting the results to somebody. So what you need to do now, currently I am into the mode shape 1, and this is deforming like this. So what I will do, I will simply say play the animation. So it will give me like how my fork is deforming. So this will be very helpful in case if you are presenting your case to maybe somebody, or if you are presenting these results in your thesis or maybe a final year project. So you can show this nice animation over there. Fine. And also you can extract this, means you can extract this as a mp4 format, or maybe you can say any format. You can export it, sorry, not import. You can export it from here, right? So again, if you want to just extract the image out of it, then you can simply take it from this end. So image to file, image from file, or image. You can simply capture your image from this one, or image to clipboard. If you click this, then you can paste this image anywhere. So just open any Word file, just say image to clipboard, and you can simply take this and paste it over there. So it is possible. Or you have one more option. So maybe just go over here, and here you can see, maybe just go to the solution, and here you have one option. uh, yeah, report preview. If you click on this report preview, I'll simply and click on this report. So what it has done, it has generated for me some report. So I'll simply go into that. So it has given me like what version I'm using, at what date I have solved this, even a nice contents. It is giving me units, geometry, coordinate system, everything it is showing for me. So you can see your total mass or whatever material properties you have defined. Everything you can see from this report. Fine, and you can simply right click and take this report out. Here also you can simply get this chart. So no need to simply copy and paste. You can directly take it from this report. So everything is available over here. You can simply maybe right click and say print and save it as PDF. Fine. So that's it regarding the first problem. We have solved it. So I'm asking you, like, if anybody has any question, he can ask me now, and then we will jump to our second problem. If not, then I'll carry out to I'll just proceed with the second problem. So I'll check what is my second problem statement. Okay, so model analysis of this knuckle. Fine. So what I will do, I'll simply double click on the model analysis, and just for your information, I can drag this and drop it anywhere. So if I don't like it here, I can simply drag it over here. So here it has, the first one is went to the B group. Maybe I can drag it over here. So now my this calculation second will be on the B group. Fine. So here I need to check the material. It's structural steel. Fine. So I directly go to my geometry. So design modeler. I'll go and check the units. I'll set it to millimeters. I will select the plane where I need to import. I'll go to files and say import the geometry. So I'll go to the assignment or session number 5, and here we have the left knuckle. Fine. I'll say open. So I can simply say generate. Fine. So my knuckle has generated. So this is my geometry. Now what I will do, I will double click on the model just to enter it into the mechanical. Okay. So I'll simply close the earlier parts we did. Fine. Now, so here we are. And before going there, I just check my units. They are fine for me. I will check the material. It's structural steel. Perfect. Now I need to define the global mesh size, and there I have element size of 3 millimeters. So I'll go in mesh. I'll click on sizing, and here in element size, I'll put simply 3 millimeters. Okay. Now I right click it and say generate mesh. So I have this nice good mesh present over here. Maybe I can still refine it, but yeah, let it be. So it is in my problem statement. And here I need to find out my frequencies in the range starting from 2500 to 10,000. Okay. So and number of modes to be find are 10. So I'll first make it to 10 instead of no. If I double click it also, it will be selecting the other option. So starting from 2500, 10,000, maybe this one. So 1 0 is more, and that's to 4 it should. Fine. Right. Okay. Now I need to give the support. So constant as mentioned in the image. So this inner portion will be fixed. So I'll simply go over here and I'll click on the inner circle portion. I'll go here and say insert fix support. Okay, so these two faces are fixed now. Now my application of boundary condition part is complete. So I can simply go to this model and say solve, or I can hit F5 to solve this. Okay, my system has solved. Now I simply click on the solution part. I'll see the table where I am having 10 modes or 9 modes. See, even if I have requested to find out 10 modes, it has given me 9 modes. Can anybody tell me the reason why it has given me 9 instead of 10? If you listen to me carefully from starting today, you can answer me this point. So why it has given me only 9 modes? So you can see it from here. It has given me only 9 modes instead of 10. Why? it has given me one mode short. Can anybody tell? Hmm? Maybe we can start from the bottom today. So 21G0484. Can you tell me why we got only 9 mode shapes instead of 10? Hmm?
Sir, at the 10th mode, it will break, I think.
Sorry?
At the 10th mode, the object will break, I think. So.
No, not like that. Why we have only got 9 because remember we have specified the range starting from 2500 to 10. And if you see over here, my ninth mode is at 8,986. My 10th mode actually is crossing the limit of 10,000. Got it? That's why I'm not able to catch over here like
Yes,
10th
sir.
mode because it is crossing my. Uh, sorry, my voice is breaking, right? Uh, okay.
Yes, sir, your
What
voice
I'll
is
do,
little bit
I'll simply. Okay, okay. Just give me 1 minute. Uh, okay, I have reconnected to my internet. Uh, yes, please. You have raised your hand. Now, where I can see the raised hands. Yeah, somebody has raised the hand. Now I think it's good, right? Or still my voice is breaking?
Yes, sir, now it's good.
Somewhat clear.
Okay, now it's better. Sorry, Praveen, I didn't get.
Clear, sir. Clear. Voice is clear, sir.
Okay, okay, perfect, perfect. Thanks, Praveen. So yes, so the reason behind like why we are not able to see the 10th mode here is we have specified the range, and my 10th mode basically it is falling out of this range. That's why it has given me only 9 modes. Correct. Here actually we are not finding like whether it is breaking or not. We are simply finding its modes. It is breaking or not, we are not interested in it. When it will break, it might break at mode number 1 also. If my natural frequency of this knuckle is 3335, and if I am having my vehicle engine producing the same frequency, then it might fail on my first mode itself, right? So it is totally dependent on my external agency which is creating some frequency. So I cannot tell from this number of modes that it is failing at this mode or this mode. That I cannot tell. It is simply dependent on whatever external or whatever surrounding it has and where it is placed and what are the vibrations or what is the frequency of that surrounding. So it is totally dependent on that. And if that surrounding frequency matches with any one of this, then and then only resonance will occur and this will fail. And if I need to design this, what I will do, I will just simply try to avoid the frequency range of my external agency, maybe frequency range of my vehicle engine, because my vehicle engine is rotating with some RPM. So I will try to avoid my engine frequency. Just means I will simply select my engine frequency to be around 4,000 hertz. So just away from this 3335 and away from 4,159. So in between that, like 4,000, somewhere around 4,000. So it will be safer. Means I'll say at the end that my this component will not fail because of my engine frequency. Fine. So you got now. So why we are not able to see here the 10th mode? Fine. So what I will do now, I will let simply all the rows and columns by just copy on the reset, and again I'll go on object reset, say right click, and I'll say create mode. I'll go and say evaluate all cells. Right. So I simply hide the mesh and maybe just check in the x-axis or yz plane direction, or maybe, and here like if you have made some changes here, maybe something like this, yeah, and this happens if you're working on this software, then such things happens. You really made a mess out of this. There is one link, just go over here, maybe in the view tab, there you have option of windows, and there you can simply come over here, and there is one option as a reset your layout. So just click on that, it will be back to neat and clean window. Fine. So this is important. I'll tell it again. Maybe if you have made some mess over here and you need to just go back to the original window size, just go over here in view, go to the windows and simply click reset layout. You will get nice and clean window again. Fine. So now I was telling you, I just go on to this file setting. I just y-axis, then I get the y-z plane. Now I'll take now the mode. Maybe this okay. I'll simply check is it is dominant. That's why I need to just check it from Z. You can right. When I go back to the other one, let's check it. So in this so this you can show, you can save it, and you can show in your presentation. Fine. Now we will check. So as we have on the 10 mode, what now I will do, just for sake of our understanding, I will simply add maybe one more zero over here, and let's rerun it. Let's see what we get it. So now what I did, I just increased the range. I just increased my range starting from 2,500 to 10,000, but I increased it to 100,000, right, instead of 10,000. So here, if I just click on the solution, now you can find out my 10th mode. So it is occurring on my frequency of 11,887 Hertz. Right, got this? Fine. So we have completed the second problem. Now there is third, fourth, and fifth. Again, three problems we have. I will solve this problem number 3. Or maybe I'll take this one first. Let's see how it goes. So this is my wheel up, and here basically I'm having different models, that's why I chose this. Let's go back. Maybe I can double click and say problem number 1. Here I'll say problem 2. And actually this is my habit, I can say. I don't enter spaces. I don't enter empty spaces anywhere. If you see in my naming style, so it's better just to avoid any errors in the programs, because the software is based on some code in the background. Any if I just say like problem this one, and maybe space and say 1, so fine, it will work. But in some cases, like in the case if your name of the file is too much longer, here also if your group size is maybe much longer, and if you are like in starting from A, B, C, so in that case, and again, even if you have similar timing, maybe problem 1, and here also if you are having problem one, same thing like that. So it what it is generate basically it is generated backend files in my local drive. So at the time, if you are saving it and maybe opening it after some days, Uh, okay. Sorry for the interruption. My Wi-Fi actually it got disconnected. Okay, I'm sharing my screen again. Okay, my screen is visible to everybody, right? So now what I was telling basically, yeah, the naming style. So if I'm having the same names, so I was on this point, right? So until now you were with me, and after that I just disconnected. Right or wrong? Just tell me so that I can repeat if we lost something over here. So I was on that naming part, right? Can anybody tell me? Hello? Can anybody tell me like where we were disconnected? So, so as per me, I am saying like I was telling about the naming style. So if my two names are same, then maybe it is difficult for the software to understand which file needs to be opened. So that's why take care while like naming the file forms, right? So I simply avoid. So it's my
Sir,
habit.
you were talking about the space.
Oh, yes, I was talking about the spacing. Okay, thanks. So I simply avoid using spaces and I just give some underscores and I simply avoid giving same names to the subsystems. I mean, subsystems means A, B, C, D, like that. So just be careful while you are renaming this. Yes. Okay. Now we will go to the next problem. Just simply double click on the model, just drag it and drop it over here just to be so here I'll write problem number 4, right? So here I'm having material as aluminum alloy. So now I'll enter into the engineering data. So here I only have structural steel as a default, so I need to use my database, so engineering data source. So I need to click on general materials. So there I am having lot of materials. So from that I need to select aluminum alloy. So here it is. I just want to click on this add symbol. So if as I click it, so I get this some notebook kind of symbol present over here. It says my material is added into my current library. So just again click on the same database. So it will close and it will show you your material library again. So here aluminum alloy it got added. Fine. So now just click on the geometry, right click on the geometry, say new design modular geometry. So we will be importing now the wheel hub, I guess. Yes, the wheel hub of a vehicle. So check units, set it to millimeters. If not, select the plane, go to the files, say import external geometry. Now go to the today's session and just check where I'm having wheel hub. Here it is. Right, so you can see the formats IGS, so basically this one, and step. So my Ansys can open both the formats, IGS and step format also. So I simply say open. Here my body is just say generate. Okay, so here I'm having my wheel hub. Simply go to view and just off my transparency, so I can see. Yeah, we have very nice wheel hub. Now I will enter into the mechanical. Just double click on the model part. So you can see, even if maybe you rename this and afterwards maybe you want to search like what was this calculation, what was this calculation. So here actually in the first row you have that this is the model calculation. This is also model calculation. If I just drag a static structural maybe, and maybe like sometimes you just rename this static structure, so then you can simply find out which calculation is this. This is a static structural one. Same thing for buckling. So if I just maybe delete this portion and just renamed it, so here you can see which is the calculation. Fine. So if you want to delete this, just click on this arrow and say delete. Okay, so this system will be deleted. Same thing I'll do for the static structure. I'll say delete. Fine. So okay. So my mechanical is open now. I'm into it. Fine. So I'll check what I need to do now. I need to specify the global mesh size as 20 millimeters. Before that, I need to define the material. So I'll go into the geometry. Now I'll go into the assignment, material assignment. So here instead of structural steel, I'll switch it to aluminum alloy. And if I go to geometry and just I'll change the display size style from body color to material, I can see aluminum alloy as my material. Fine. Okay, now in the meshing, I'll go to the sizing and just check the size as 20 millimeters. So here I'll enter in element size as 20 millimeters. Now I'll right click and just say generate the mesh. Okay, my mesh has been generated, but I think this is little bit coarser one, so I can simply go some point below, maybe I'll say 10 millimeters. Let's see how it mesh. Okay, so fine. So I think we will go with this mesh. And now the boundary condition. Let's check where I have the constraint. So I have the constraint on this bearing face because my wheel has been mounted on some of the bearing. And again, I am having a frequency range starting from 5000 hertz to 20,000 hertz. And I need to find out 10 number of modes. Okay. So I'll simply switch it to 10 instead of 6. And here I'll start it from 5000 to 20,000. Fine. Now I need to add the fixity. So fixity is here. So this will rest on my bearing and this is my wheel. So I will fix it at this location. Just right click and say fix support. Fine. So my application of boundary conditions part is complete over here. Now I will just simply go to this model and say solve. Okay, now it has calculated for me the 10 number of modes. I can see it from here. Just click on the solution. You can see this table. Now I can simply click on this one, or there is one more option available. If you do not want to click here and just to add your mode shapes, you can simply go here, right click over here, say deformation, maybe total deformation, and here you have mode number 1. Then you can simply go over here and say duplicate, maybe duplicate or duplicate without results, both will work. After duplicate, you can simply change it to 2. So same things are happening, what I am doing from that table, copy and create a mode shapes. So you can do it here, but this is a little bit tedious. So this is somewhat simpler one. So just right click and say create mode shape results and say just evaluate. Fine. So here we have results for the different frequencies. So these all are the natural frequencies. Fine. So yes, here we have completed the third problem for the day. Now there are two problems left, and I want now somebody from you to guide me for solving this problem number 3, because we already solved 3 problems today. So I just start with the first step. So I have opened the model. Now you need to guide me. Somebody of you need to guide me. Uh, and yes, for them who are thinking like we are done for today and we will be doing same calculations. So you are wrong, because now I will be giving you like one tip, like how you can calculate the pre-stressed model calculation. So it is not here mentioned here or here in our problem statements, but this is something extra I'll going to tell maybe in last 10 or 15 minutes. So you need to be with me for that. If you want to learn like how we can solve a pre-stressed calculations and how we can find the natural frequency for pre-stressed model and what is exactly pre-stressed model is, so that I can explain you maybe on the same model, so which we are going to solve now. On that only I will explain. So for that I need somebody from you to guide me to solve this. So who will take the lead today? Who will take the lead today? Anybody? Maybe I just started from bottom today, so I had with this guy, and now maybe Praveen, can you?
Yes, sir.
Okay, perfect. So that's the spirit. I like it. Just go on. So I'll open the problem over here in the right side. Just go on and tell me like what I need to do. I have already taken the system D. So now here I'm having structural steel.
Sir, we want to go to engineering data and change the materials.
Is there a necessity to do this? Because we have structural steel.
We need to check it, sir, because
Okay, fine. So I checked it and it is available over here. So it's by default. Fine. Now,
sir, then we need to make that model, sir.
okay. So I need to go to the geometry, right? I need to double click on this geometry. Yes. Yes, Praveen, I need to double click on the geometry. Am I
Yes, sir,
correct?
yes, sir. Yes, sir.
Oh, no, no.
Right
Actually,
click,
I
sir.
need,
Right click and then we
uh,
need to select it, sir.
okay, yes. So I need to right click over here. Oh, by mistake, what happened from me, double click has happened from me. See, you're seeing over here, like it has now going into the space claim. So it is saying starting the space claim. So we need to avoid this. We can do it in space claim also, but again, we have some limitations or maybe, yeah, again there are some pros and cons, but yeah, by mistakenly we did that. I can show you, but I request you don't follow this procedure, otherwise no, I'll close this. If I want to, then I can tell you, but it will unnecessarily create some doubts in your mind. That's why we will stick to design modeler. Just forget about space claim. Okay, now what I have to do?
So select a plane and then import the models.
Select the
Import the models you want to.
no. The first step always should be checking your units. Whenever you open any window, the first part always should be check the units. Fine. Now, the second part should be to select any plane and then import the model. Right. So we were at session for today. So here it is bridge. Okay. Now what I need to do? Yes, Praveen, what I need to do now? Are you with me? I think we have lost the Praveen. Fine, no issues. I'll tell. Maybe now I need to generate whatever we have imported over here. I need to generate that. So right click and say generate. Okay, so here I'm having that bridge kind of thing. So it's literally a dummy bridge. Fine. Okay, Praveen, welcome again. Welcome back. So I have done one step for you. I have just click on generate button, and now model has been generated. Now what I need to do?
To go into the models.
Okay, perfect, Praveen. Nice. So I need to enter into the mechanical now. That's why I will just simply double click on model part. So row number 4. Then I will be into the mechanical. Fine. So we'll go back to the problem statement. So do we need to define any elements? Yes, it is. So I need to define global element size as a 20 millimeters. So what my next step should be? Yes, Praveen?
To go in the mesh.
Okay, before that, I need to check material units and oops, sorry, I'm into the wrong window. I need to check units whether they are in millimeters. They are, yes, fine. I need to check material. It is structural steel, fine. Then I need to go to the mesh, and here I need to specify the size, correct? As 20 millimeters. Now done. So what is the next step now? So I was somewhere here. So my next step would be
The settings you want to specify the number of modes.
okay, perfect. So I just go into the analysis setting and I specify number of modes as 10 and specify the frequency range starting from 0 Hertz to 5000 Hertz. So simply type here 10. Here I just double click and say yes, 0 to 5000. Okay, done. So now what I need to do? Constraint. Constraint should be at the bottom face. So what I need to do now? I need to add a constraint. So how I can do?
Fixed surface.
Fixed to support. Okay, but from where I can add that?
The bottom face we need to edit.
Yes, bottom faces I have selected. But how can I add those over here? So from where shall I add
Right click,
this?
we have to right click and then
Okay.
you have to do.
Okay, right click on model and say insert and say fix support. Perfect. Nice. I'll simply check it again. So, okay. So we are done for the boundary condition. So my only portion remaining is to solve. Correct? I'll say solve. Okay, perfect. So my calculation part is done. So now what I need to do? So what should be my
You
last
need to
step?
copy the table that has it.
But I'm not seeing any table over here. So why? It is not visible. So how I can simply copy it? Hmm? So somewhere I need to click so as I can see that table over here. For that, I need to click on the solution tab. So if I click on my solution, then and then only I get results. Fine. So whatever in the model is my pre-processing. So whatever under the solution tab is my post-processing. Oh, sorry, I got just wrong. So whatever under my model is my processing. So whatever above this is my pre-processing. And whatever in the solution is my post-processing. So you need to click on the solution to see these results. So these are nothing but my results, correct? And to see the results, you need to be in post-processing, right? So here, how can I select this then? Then means I need to press control, right? How can I select this?
So we can select the top and then we can give it.
Okay, selecting this empty cell. And then,
Copy results selected option. Right click.
okay, just right click and say create mode shape
Copy.
results.
Nice.
Okay, so it will automatically create my mode shapes over here. And now I need to right click over here and say evaluate all results. Okay, perfect. So it has given me very nice mode shapes. So let's try animating any one. So I would like this one. So let's animate this. Okay, perfect. Nice. So now we are done with this problem. Now what I will show you what is mean by pre-stressed calculation. I'll show you that. So I'll simply drag it to this point. Maybe now I will say a static structural. So I'll drag it and maybe I'll put it over here or maybe here. Fine. So what I will do, I'll keep my material same. I'll go to my design modeler. I will import the same bridge again into static structural. So maybe just check units, set it to millimeters, click on the plane, import external geometry, go to the assignment number 5 and say a bridge. Perfect. So generate. Fine. And now I just enter into the mechanic. Fine. Now I'm into the mechanical. So here what I will do, I will apply same boundary conditions, maybe same fixed supports. So I'll say fixed support. I'll click somewhere here and say apply. And in mesh, I need to give exactly similar mesh what I will be meshing in my model calculation, right? So I have given the fixed support. I have given the mesh. And now I will be adding maybe some force. So I'll be having some load of say in component way in Z direction 100 Newton. What I'm doing over here, just for sake of understanding, I'm adding some load over here. So this is, consider this is one bridge, and maybe some vehicle is standing over here. So now this is in the case of like pre-stressed modal analysis, because bridge is not like without any external weight, so it is with the external weight. So now what I will do, I will simply solve it. Okay, so maybe from here I can see the deformations also, means in this direction. Let's simply check the deformations. So x z direction, maybe you can see somewhere like it is deforming like this. Fine. So now we have one loaded bridge, loaded with some mass. For the time sake, we took it as like 100 Newton. So these solutions I am having, and I need to carry out the model analysis for this bridge, right? What I will do, I will simply take the model, maybe move this one, and I will just drag it and drop it into the solution. What I did, I took the model, maybe for time being, I'll simply move this system away, the earlier calculations away from this. So what I did, I simply drag the model group and I just drop it to the solution window. Means I need to use this solution data to calculate my model analysis. This solution data into my setup. Means this solution data as input or as a boundary condition for my model calculations. Got this? So same thing we did yesterday for buckling analysis, right? So same thing has come up over here, like same analysis settings. So now only thing is to just change it to 10 and change it to, I think, 0 to, I guess, 5000. Let me check it again. 5000 is fine. So I'm having the same mesh, and I just need to apply again the boundary condition. So instead of applying it again, I have one shortcut over here. Just click on this fixed support, just drag it and drop it on this model one. Also something has happened, I don't know. Let's try to fix it, why it has done, but it should work. I don't know why it has given me this error. Let's delete it and go it with our usual case, maybe insert. Okay, fine. Oh, I forgot, because I have already given fixity over here and I have taken results with this fixity. So no need to define the support again here in my model calculation, because I'm already extracting results with the fixed support. So this is fine. So all the boundary conditions I'm having defined over here. So no need to define it again in this model tab. Fine. So I think only analysis setting I need to define number of modes and the range. So I just need to right click and say solve. So let's see what results we get. So this is nothing but my pre-stressed model calculations. So this part actually is a little bit addition to the what we have in the assignments. Fine. So now I simply click on the solution tab and I can get this tabular data. So just click on the empty cell, right click and say create mode shapes and say evaluate. So I have this table. Maybe now what I will do, we will compare the results with our earlier calculation. So I have results for this model one and I have results for this uh, what I will say, the pre-stressed model one. Let's compare the both. So let's see. So here I'm seeing my first mode shape. If I just go and check my first mode shape, oh, what a wonder. I'm having exactly similar results. I'm having exactly similar results. Then what I will do, I will increase the load, maybe in the amount of 10,000 Newton. Let's solve it again. So my results were similar because I was applying very small load, so 100 newtons. So maybe if I calculate it in kg, then you can uh, say it's very less. So I just go to tabular data, and it is not giving me any difference. Let's check the deformation. So still it is very small. Maybe I need to increase loads like this. Let's check. Okay, and now I think we will get good results. So say solve, because now my beam is deforming by 7 millimeters. So earlier it was into like 0.0000 in that range. Okay, perfect. So now you can see the exact difference. If I'm having some load on that bridge, somewhere here, then my first mode, and here my first mode. Do you get the difference? Maybe I will simply off this and maybe say I just want to see undeformed body. Here also I'll say undeformed body and simply say with the edge. Can you notice the difference in the color form? So whatever I am having first node, it is occurring at these corners, but here the node with mode it is occurring, it is at my center because I am having some load over here. Got my point? Why actually it is necessary? Means maybe if you are having this kind of bridge, and if you are thinking of applying some weight in the middle of your bridge, maybe you might be thinking to put some structure at this end, or maybe some statue. So it will have some its self weight. So because of that addition of some load, it is pre-stressed condition. So it is already having some load. So it will have different natural frequencies than it is having without any loop. So this is the simple difference between these two cases. One is like a simple model calculations without any preload, and this is one with the pre-stressed condition. Fine. So you all got the difference between these two calculations, or any doubt if anybody has? So can anybody explain me what is difference between these two? Like without any stressed condition model analysis and with a pre-stressed model analysis. Can anybody explain me the difference? So we just finished that topic. So can anybody explain me what difference? So maybe now you can take the lead. You can tell me what is the difference. Mm-hmm. F010. Can you tell me what is the difference between two cases we just saw? So maybe here it was, right? So this is nothing but a pre-stressed condition. Hmm? Or anybody other than her? Can you tell? Mm-hmm. Or Yukesh, can you tell me? So what is the difference? Yeah.
Sir,
Mhm.
in this case, a model is created before itself with some force. Then it is added to with some.
Mm-hmm. Yeah, you are
Sir,
correct.
static structure, from static structure, the force is a model with force is created, sir.
Mm-hmm.
Then we are adding the model to solution of the static structure, and we are
The
considering
natural
the
frequency.
conditions in models, sir,
Okay,
for
okay,
some
perfect.
frequencies and tables, and
Okay.
then then we have then we will solve we will get the results, sir.
Okay. You are absolutely correct. So this is nothing but my pre-stressed model calculation. And in like only model calculations, we haven't considered any external load, right? So this is only for the single part. So maybe in this example for bridge without any external load. Perfect, Yukesh. Thank you for your answer.
Thank you, sir.
So yes, now I guess we'll just left with one problem for today. Maybe I can simply solve it with with a super fast speed. You can simply check what steps I follow. Let's go. I need to check the problem statement. Structural steel 20 millimeters element size 5000 to 15,000 hertz and 12 modes. Okay, just go on to the engineering or design modular because my material is structural steel. So just check unit, set it to millimeters, go to the import site, again go to the file number and then to the gear. Fine. Select open, say generate. Here I am having a spur gear. Just click on the model just to enter it into the mechanical. Let me close earlier windows. Otherwise my PC will get hang and it will be very slow. So I'm into the mechanical. Fine. So my mesh size is 20 millimeters. Let's set it. So I just forgot to check units. I check it millimeters. Fine. I need to check the material. It's structural steel. Perfect. So just right click and say generate mesh. Now in constraint, I need to add the fixity into this middle circle portions. So two faces I selected, and in analysis setting instead of 6 I need to make 12, and in the range starting from 5000 to 15,000. Fine, right click and say solve. So here I am having 10 modes. I just click on this empty cell, right click and say create mode shapes and say evaluate. Perfect. So I'm having these number of frequencies. So while designing this gear, I just check these frequencies and I check the frequency of my motor, or I'll say whatever motor is driving this gear. So I'll check the frequency of that motor and I just uh, uh, try to avoid the frequency of that motor. And if I need, like if in the case happens like my motor frequency is maybe somewhere around 5871, then I try to change my natural frequencies. And how I can change my natural frequencies? Maybe by changing its shape. So I simply add some material, I simply add some thickness, in by doing that also I can change my frequency, or I can change my material. I can have a different density material with a different mass. So with that my natural frequency will change. So basically you need to play with this equation. So the equation I showed you earlier, this one, maybe I will go back to some, yeah. So you need to play with these two terms. So this is K means nothing but stiffness. If you are adding or removing material, my K value will change. And second is mass. If you are changing the changing these terms, then surely your natural frequency will change. So that's nothing but your design or design optimization. That's the thing you are doing when you are designing some components. So in real world, this is the case. Fine. So yes, I think I'm done from for the today's session. If anybody has any question, he or she can ask. Do you have any question for today? Meanwhile, I'll just check what we have for tomorrow. Okay, tomorrow we will be having thermal calculations. Fine. And we still left with assignment number 2. Okay, so this is also important session. So these are especially like you pronounce it as ba instead of somebody try to pronounce it as baja. I know, but it's ba basically, and for them this analysis is essential. So this is one of the criteria for selection. Okay, so do anybody have any question? So our tomorrow's session will be on thermal calculations. So we will be analyzing maybe pistons of some vehicles. So there we have in the engine some temperature, some pressure. So those cases we will be solving tomorrow. So tomorrow's session will be interesting, and yeah, let's see how it goes. But for today, do anybody have any question? I will ask again. So we have more 5 minutes to take up your question. Maybe any general questions you have or any doubt. Maybe somebody is thinking what we are doing, whether this is very really necessary. You can ask such questions also. I can answer that. I'm doing such work from last 10 years. I'm into the industry and I'm doing such things from last 10 years. And I know like how important these things are. So when I was in like of your age and studying into the engineering, so at that time also I used to think like whether like this integration derivatives is like are they really necessary in real world life? Now I can say yes, they are very very important, and yes, they are applicable in all your real world problems or calculations or designs. So you can ask me any question. uh, Simply you can ask whether it is related to today's session or maybe the sessions we already gone through, or maybe any questions related to CAE, maybe modeling, something you can, anything you can ask. So I'm giving you more 3 minutes. Hmm? I think you guys are very brilliant. Means you understood everything, right? That's why you do not have any question. Hmm? Am I right? Don't. Mm, okay then. I think. Let me just check. Okay. Okay. Nice.
Sir,
Yes. Yes. Please, Yukesh.
sir, sir, one small question, sir. Sir,
Yes. Yes.
I Sir, why we are using static structural for force and frequency for models? Sir?
Why we are using static structural for?
The force acting on the object, and for calculating the frequency, we are using the model type.
Okay. Yeah, very good question actually. Uh, thanks for asking such question. See, in analysis systems, we have variety of calculations available. So static structural is a group where I can solve uh, any problems related to static loads. Any problem related to static loads. So there are some systems which are saying like transient structural. So here actually what we are solving the loads which are changing according to time. That's why this is transient structural. And in model, basically we are calculating its natural frequency. So these are different sets, means these are all different varieties of calculations depending on my application of load and depending on my requirement. So my requirement, if it is a frequency, then I cannot find it out from static structure because it only deal with the static loads. It does not deal with any vibration. So if I want to check vibrations, then I simply need to go in model or maybe in random vibration case, right? So that's the main difference between these two, like why we are using static structural at some point and we are using model at some point. And again, we have also used buckling at some point because in buckling, it is not basically dealing with any frequency. What it is dealing with, it is dealing with how my structure behaves, means how my stiffness changes or how my rapid distortion or rapid my stiffness goes away and then after some time it comes back. So this is main phenomena of the material which is buckling, right? Here actually input is totally different. For buckling, I have shown you yesterday the curve, so it is not exactly similar to my stress strain curve. So my stiffness like varies according to my load. So that's the difference why we have this different systems and why not we just calculate in one system. So am I answered your question, Yukesh?
Yes, sir.
Okay, thanks for asking a very good question. Uh, okay, do anybody have any question or shall we stop for today then? Mm, okay, I guess we are done for today. And yes, I wish you a very good night. And yeah, see you tomorrow for the next session. And bye bye.
Thank you, sir.